Hello there. Let's do subnetting. Yeah, that scary thing we've been building up to. The video on the RP, the video on the numbering systems and the binary and decimal conversion, all of that was leading up to this section, which is very important to understand for Network Plus, and even more so if you're planning to pursue a career in networking after Network Plus. Because when you do something like a Cisco CCNA, I can guarantee you they're going to assume you're already familiar with subnetting, maybe even completely comfortable and capable of it. So let's get into it. Now, before we get into the messy stuff, let's have some formula that's going to make our lives a little bit easier as we're doing all of this work. These formula I want to show you are going to help us work out the number of new subnets we're going to be creating, the number of hosts we're going to have per subnet, and something called the increment, which is going to be very helpful later on. So first, let's deal with that network formula. The formula is very easy. It is 2 to the power of n. And this is where n is the new network bits we will be creating with the subnet mask. These will be the binary ones that we will be setting in the subnet mask. Then we have the number of hosts, and that is 2 to the power of h, and whatever that is, minus 2. This is where the h bits are the host bits left behind in the subnet mask, which are the binary zeros. Now, the reason for the minus 2 is because every network has 2 addresses we cannot use. The very first address, which is the network address, and the very last address, which is the broadcast address. The network address is used by routers to identify the whole network, and obviously we don't want to give that IP address to a computer or a printer or anything like that, because then we don't want that device appearing to a router as though that's the whole network. And while the broadcast address is used when I want to send a layer 3 broadcast to everybody in that network. And obviously we don't want to use that address on one machine, because every time we talk to that person, everyone's going to hear it. And maybe they don't want that. And then we have the increment. This value will be useful later on, but it is 2 to the power of I. Now, this is where I is the host bits left behind in the octet where the mask ends. Now, that little piece there that I emphasized will probably matter a bit more when we're playing around with subnetting Class A and Class B networks. Class C is not going to be too special or different. But unlike the hosts, there is no minus 2. So we're looking at the binary zeros that we left alone, but only in the octet where the mask ends, or basically where the binary ones stop. And this is going to help us with figuring out what's going to go on with the new subnets and where they start, where they end. Believe me, this is going to be a very helpful value when we start working out all these new networks we've created. But the formula are, in summary, total number of networks 2 to the n, hosts per network 2 to the h minus 2, and the increment is 2 to the I. If you want to quickly write these down or make a screenshot or something, go for it. I'll give you a chance to pause. Right. So let's first understand, what are we hoping to do with subnetting? What's the whole deal with this thing? So the idea is we're going to take a network and we're going to break it up. We're going to create more networks, and this will hopefully help us basically get a more efficient use of the address space. Now, when we do this subnetting, we can either go for a certain number of networks, or we can go for a certain number of hosts per network. I'm not able to guarantee the results of both. I can only go for one of the two. Now, sometimes you won't always get the exact number you're after, but that's okay. The goal here is to reduce address wastage. And as long as we get close to what we're after and keep the address wastage to a minimum, that's what we're basically trying to achieve. Now, what ends up happening is when I make my subnet mask longer by 1 binary bit, this is the effect it creates for us. It effectively doubles the number of networks we have, and it just over halves the number of hosts we have per network. It's kind of like if I take a pizza. Yep, it's that one that came from that video earlier. And if I slice it in half, I've got now 2 items of food. However, these 2 items of food are smaller than the original. And if I go and slice it again, there we are. So I'm pretty glad that I did not throw that sausage pizza away from the previous video. Moving along, let's do some subnetting. So first up, let's get that binary to decimal conversion table up. Remember, we only need the first 8 columns, 1 through to 128. Also, you want to stick the 2 to the power values as above the numbers as well, because as you saw, the formula we're going to use to work out where we're at and what our progress looks like is a lot of 2 to the power of this, 2 to the power of that, and 2 to the power of the next thing. All right, so let's take an IP address, or a network address if I want to be more technically correct, like 192.168.0.0. And let's set a goal for ourselves. Let's say we're trying to achieve a minimum of 20 hosts per subnet. Sounds like an interesting goal. And the thing is, if you look at a Class C network normally, it gives you 254 usable IP addresses. And I can tell you right now, there's going to be a lot of LAN segments at your workplace, at your school, wherever it is, that doesn't need that many devices. So 20 sounds a bit more reasonable. Now, the first step we want to do, or actually even before we start the first step, we just want to quickly double check ourselves. 192.168.0.0, that is Class C, right? And Class C's classful subnet mask is 255.255.255.0. And that is what I'm going to be playing around with. So step 1 is to take this classful subnet mask and rewrite it in binary. So let's quickly jot it down again, 255.255.255.0, and let's work it out in binary. Now, if you remember from my previous video on the numbering systems, there's a quick trick for you. 255 is 8 binary ones. And then 0, well, that's going to be very easy, because whether I write 1 0, 8 zeros, or 8 million zeros, it's still 0. But I'm still going to put 8 zeros here when I write this in binary, because I want 32 bits. I want to play around here. Now, before I start playing around too much, we've got to be careful. What is already set to binary 1? We can't touch it. If it's already a network bit or a binary 1, we can't touch this. So let's mark that red so that we know we can't screw around with those binary bits. Then step 2, we're going to start converting host bits or binary zeros to network bits binary 1s. Now this is going to be a bit of a slow process, but what's nice is we're going to see the effect of every single binary bit that we are going to flip from 0 to 1. And what we're doing is we're working from left to right. However, we can't touch those ones that are already binary 1. So I'm going to be working from this binary 0 and then working to the right. Now, before we get too carried away and have too much fun, let's just put the formula there so we can keep track of our work. Firstly, I just want to deal with the number of networks I'm going to be creating and the number of hosts per subnet. And let's flip a binary 0 to a binary 1. Okay, I'm coloring it in blue so you can see more easily. Now what we effectively have done here is decided to move where the network address portion of the subnet mask ends and where the host bit begins. Similar to what we did in that video on IP version 4, imagine a line, except this time it goes after the last binary 1. And everything to the left of it is my network bits. And everything to the right is my host bits. Now please be aware when I say network bits, I'm only going to count the new network bit. Not all of them, at least not right now. And then the ones to the right, those are my host bits left behind. They're going to be used to identify which parts of the address represents the individual system within the network. Now, let's plug those into our formula. 2 to the n, so we've got 1 new network bit. And h, we've got 7 zeros left behind. So our formula is going to read 2 to the 1, or just 2 basically, for the number of networks, and 2 to the 7 minus 2, which is 2 to the 7, 128, minus 2, gives me 126 hosts per network. So I'm a lot closer to that 20 hosts I'm after, but I reckon we could get a lot closer. So let's try again. Let's flip another binary bit to a 1 and see what it looks like. So now that line's moved across a bit, and we've now got 2 new network bits, and we've only got 6 host bits left behind. Let's plug that into our formula and see what we get. So 2 to the 2, I've got 2 new network bits, so that gives me 4 networks, because 2 to the 2 is 4. And then 2 to the h, which is now 6, so that's 2 to the 6, gives me 64 minus 2 is 62. Okay, much closer to the target of 20. But I think we can probably get a bit closer than that. While you're mastering this, the whole game is move it by 1 binary bit and see what you get. Keep trying to get as close to the target as you can until you either hit it or you miss it. I'll show you what you do now though. So let's try another step and see what happens. So let's go for a 3rd binary bit, going from 0 to 1. And obviously, we've now got 3 new network bits and only 5 host bits left over. Let's see what happens when we plug that into the formula. 2 to the 3 for the number of networks gives me 8 new networks. And 2 to the 5, which is 32, minus 2, because remember that network address and broadcast address that each of these new networks has, is going to give me 30 hosts. Now, I know that this is as close as I'm going to get, but I've got a lot of practice and experience with subnetting, so I can tell the next step is a step too far. However, you might not see that yet, so let's go and see what happens when we go a step further. So I'm going to mark that bit in a slightly darker shade of blue, and let's see what the effect is. We've now got 4 new network bits and only 4 host bits now. 2 to the 4 gives me 16 networks. Okay, quite a few subnets now, eh? From 1 network I got 16. Wow. But 2 to the 4 is 16 minus 2 leaves me with only 14. That is 6 less hosts than we were aiming for. Remember, the target here was minimum of 20 hosts per subnet. We fell short of that, didn't we? So we've gone too far. All right, we go back a step. Simple. Now that we're back a step, let's carry on. Our next step will be to see what our new subnet mask looks like. Now the nice thing for us is the first 3 octets didn't change. So we can cheat a little bit and rewrite 255.255.255. But that 4th octet is definitely going to be different, and it's definitely not going to be a 0. So let's see. The 4th octet in binary is 11100000. Well, off the top of my head, I know what that is, but maybe you're not that familiar with this binary to decimal just yet. In which case, don't be ashamed to plug it into the table there. 128 plus 64 is going to give you 192. 192 plus 32 is going to give you 224. Fantastic. So although that looks very weird, and you might feel like that's wrong, I promise you, that is now the new subnet mask. 255.255.255.224. Cool. Now what's next? Well, we've got a subnet mask, but where do these 8 new networks we've created begin and end? Well, we're going to go and plot those new subnets in a table. But to do that, we're going to need the increment. The increment is going to be very, very helpful here. The increment is 2 to the power of I. And in this case, I is the host bits left behind, or the zeros left behind in the octet where the mask ends. Now, when you're dealing with class C and you're subnetting that down to a smaller number of hosts per network, what ends up happening is your host and your I bits are the same. So it's h/i then. So that means it's 2 to the 5, which is 32. Okay, cool. So before we get carried away and get overshot with the table, let's just have the start of the table and see what we had originally. So before we subnetted, we started with the 192.168.0.0 network. That is the network address. In that network, the very first valid or usable host address is 192.168.0.1. And in that network, the very last usable address is 192.168.0.254. Its broadcast address is 192.168.0.255. Remember, it's the network address and the broadcast address that is the reason why we had that -2 in the formula for the number of hosts per subnet. And originally the subnet mask was 255.255.255.0. Well, we've taken that one network and we've turned it into 8 networks. So we're going to need a bigger table. So let's start out with some extra columns, like the subnet number all the way on the left hand there. Then we'll still have the network address column, the first valid host address column, the last valid host address column, which are very useful because those are addresses that we can use, the broadcast address, the subnet mask, something called CIDR or CIDR, I'll explain it just now, and then to turn this table into something a little bit useful later, a location column, which will be pretty cool when we get to it. First up, let's number the networks 1 through to 8. And what will be useful is to work out the new network addresses for all these subnets we've created. So the way we're going to populate each one of those rows for the first column is we're going to start with the given network address, which was 192.168.0.0, and we are going to add the increment value to the octet we worked in to work out the next network's address. So we worked in the 4th octet, which was the second 0. 0 plus 32, which we worked out to be our increment earlier, is going to give me the second network beginning at 192.168.0.32. Cool. Now to work out the next network, I add the increment to the octet we worked in again. So 32 plus 32 gives me 64. So the third network is 192.168.0.64. I do it again. 64 plus 32 is 96. 96 plus 32 is 128. 128 plus 32 is 160. 160 plus 32 is 192. 192 plus 32 is 224. And 224 plus 32 is 256. Wait a minute. We don't get 256s in IPv4. Whoops, that was a bit of a mistake. But you know what? That mistake actually is kind of useful. Because if you go one step past the last subnet you create and you get a 256, you know you're on the right track. You haven't made a mistake. And remember, if you're doing this in the exam, the last thing you want is to make a mistake while you're under pressure because you might not notice it. So call that a happy accident. Plus, it's also going to help us out with the next thing. Because the next thing that's going to help us is filling out that broadcast address column. Now remember, the broadcast address is the very, very last address in that network, but is not usable. So the way to work it out is this. You look at the next network address and subtract 1 from the octet we worked in. So for this broadcast address, I look at the next network address, which is 32. And I subtract 1 from it, and that should give me 192.168.0.31. Then for the second broadcast address, I go and look at the third network address, which is 64. 64 minus 1 should give me 63. So let's see. Next one is going to be 96 minus 1, gives me 95. 128 minus 1 is going to give me 127. 160 minus 1 is going to give me 159. 192 minus 1 is going to give me 191. 224 minus 1 gives me 223. And then our little mistake over here actually is still useful because 256 minus 1 is going to give me 255. Hey, so it had a purpose. Now that it served a purpose, it can go away in a moment. But let's talk about the next thing. The next thing is we want to actually know what IP addresses we could use on computers or servers or printers or the router's interface so it can act as a default gateway. So let's go and check it out. The first valid host address and the last valid host address are going to be super easy to work out as well. Because for the first valid host address, I look at the current network's network address and I add 1 to the octet we worked in. Because the very first usable IP address is the first one to come after the network address. And then for the last valid host address, I look at the broadcast address and I subtract 1 from the octet we worked in. Because the very last valid or usable IP address in a network is the one just before the broadcast address. Cool. So let's see. 192.168.0.0 plus 1 should give me 192.168.0.1. And then 192.168.0.31 minus 1 should give me 30. 192.168.32 plus 1 should give me 33. 63 minus 1 should give me 62. 65 should be the next valid first address. Then for that network, it should be 94 as the last valid host address. 96 plus 1 gives me 97. 127 minus 1 gives me 126. 128 plus 1 gives me 129. And then 159 minus 1 gives me 158. 160 plus 1 gives me 161. 191 minus 1 gives me 190. 192 plus 1 gives me 193. 223 minus 1 gives me 222. 224 plus 1 is 225. And 255 minus 1 is 254. Sorry if that was a bit boring, but there's all the values. And you can see those simple little rules we have for the network address, the first valid host address, the last valid host address, and the broadcast address makes it pretty easy to plot this out. And I promise you it's going to work for all variations and all possible subnets. Now, obviously, all of these 8 networks are not going to be existing with the original subnet mask. They exist with that new one we created, which was 255, 255, 255, 224. All right, so the next column is the CIDR, or CIDR, as it's normally pronounced. So what's it all about? Well, first of all, it is an acronym for Classless Inter-Domain Routing. And what it does is it just is a count of the number of binary ones that are in the subnet mask. Now, by counting the number of binary ones, you can actually express or write the subnet mask in a more compact form. And routers like to use this nowadays, as it means that when they want to share information with each other about an IP network, it means that instead of sending the 32-bit network address and then a 32-bit subnet mask, they can get away with sending just a 6-bit value. Now, subnet masks are always going to be written as continuous ones, and then they become continuous zeros where the mask ends and the host bits begin. So it's quite easy to actually write. And once you get used to CIDR notation, it actually becomes a bit of shorthand for us. So let's play around with some examples. We already know that 255 is 8 binary ones. So if we take a classful subnet mask of 255.255.255.0 and write that out again in binary, we get 8 binary ones in the first octet, another 8 binary ones in the second, another 8 binary ones in the third octet, and none in the fourth. So that is 8, 16, 24 binary ones. Or in CIDR notation as we write it, we usually express it as /24 right after the IP address or network address. Alright, now let's try that out for our current subnet mask that we created, which was 255, 255, 255, 224. First 3 octets were all 8 ones. It's the fourth octet that's going to be a little bit interesting, because there we've got some extra ones. So the first octet gives us 8 ones. The second octet gives us 16 ones. The third octet gives us 24. And then we've got another 3 in the fourth octet, which gives me 27 binary ones, or /27. So I can write my CIDR notation for these networks as /27. Cool. Either number is going to work fine. But if the CIDR notation is a little bit off-putting, don't worry, you'll get used to it. Now, for that last column, we can make use of it to keep track of where we're using these new subnets we're creating. So not only have we visualized for ourselves what this is going to do for us, it's also making our lives a lot easier to track our network and just document it properly. So I can say I'm using that subnet on the first floor of the building, that one on the second floor, that one on the third floor. Fantastic. Now, if you're worrying about how would they ask this in the exam, they're probably not going to ask you for an entire process on subnetting. What they would probably say is, hey, here's an address 192.168.0.100 with a /27 mask. What's the network address for it? And you'd have to work out, okay, /27 would give me 255.255.224. Increment would be 32. probably started with 192.168.0.0, so let's work our way up. .0, .32, .64, .96, .128, wait a minute, 100 would appear between 96 and 128, so the network address must be 192.168.0.96. So basically that asks you for a part of this process to check that you understand this. But you know what? There's 1,001 ways to do subnetting. And if this one doesn't click for you, that's okay. Don't be afraid to go and explore other methods from other people, either here on YouTube or anywhere else you find help and guidance for subnetting. It took me a while to come to grips with this, but once I got to grips with it, it's like riding a bicycle. But nonetheless though, I'd like to thank you all for watching and hope you enjoyed this and you got some value for this. If you have any friends and family members or colleagues or peers or anybody like that you think is interested in Network Plus, don't be afraid to share this video with them. And if you haven't already done so, don't be afraid to drop a subscribe. Otherwise though, I'll see you in the next video.